Okay, I'm Mark Gomez.
I'm RJ4.
We're starting our science fair project, and it's dry ice. Dry ice is a weird thing. I don't know why it's called dry ice. I forgot, and maybe I'll say it later. But before we start our project, we were interested in two things. One, like a bomb, which we just did a minute ago, and it was loud as crap. And I'm wondering, since you cut out the center of a cup at the bottom, it makes a ring of smoke. I'm wondering how it makes a ring of smoke later on. But first, I want to see how it works when I actually do the project.
The reason why we're looking for the time of evaporation and the amount of smoke will change because the research by carbon dioxide it freezes at negative 109 degrees Fahrenheit or negative 79 degrees Celsius. Carbon dioxide is what makes dry ice. So, why would this be so important? Think of this. Have you ever been driving through fog and you can't see? Or does how hot or how cold the area matters will change the fog, or faster it will disappear?
Cover up my feet. I keep the knives there. Okay, before we start our real project, we were interested in something else, which was one, exploding a bottle with dry ice and water, which was a funny thing to do, but a bad idea because it was really loud.
It would attract a little too much attention, maybe.
Yeah. And another one is figuring out how a cup and you hit it with saran wrap on it makes a ring of smoke. So, first thing, you cut out the center of it, like with scissors or knives. Then
Wrap the bottom with
top,
saran wrap.
top with saran wrap. Grab the little band. To make sure this stays on when you hit it, like this. Grab a rubber band.
You grab a rubber band and bring it over the saran wrap.
Saran wrap, so when you hit it, it won't like fly off. Then, here, let me see the colors.
And then,
Okay, and now you grab like
some dry ice.
Some dry ice. Got some water upstairs. Like, tap water would work.
I think this should be enough.
Like grab like half a cup of water, and grab like try to get your dry ice to the small would work. Get like 3 in here, 3 or less would work. We're using 3 right now. And then drop in the water. Just pour all of it.
Alright.
And as you can see inside of it, it's smoking already, so when you hit it like this, it makes the ring of smoke, kind of.
If it's a perfect circle.
If it's a perfect circle, but it's not, obviously. But
Now,
the thing I'm wondering is, when you hit it and you make the ring of smoke, how come the center part evaporates faster than the outer edge?
or if temperature changes the reaction.
Of the ring of smoke and the time of evaporation. We're going to let this sit right now for the rest of the time. When we start, now we're starting a real project, which is this technically. This is the time and amount of smoke the amount of smoke and the time of evaporation. The key is the one that we're actually comparing all of it to, which is room temperature water. And then the other 2 trials that we're doing, 4 times each for every single one, is boiling water and like cold water, like when you put it in the fridge and it's like really cold water. And then since while we're waiting for the room temperature water to get to room temperature, obviously, we wanted to show you that after we made the ring of smoke, we saw something at the back. You could see a little, like the bubbles coming there. But it's a little foggy because the dry ice and smoke. A little dry ice and smoke makes it a little different and hard to see. Hard to see. So that's a cool thing that we saw as we were like waiting for the water to go to room temperature. And inside, you see the smoke, and you could kind of hear the bubbling a little. And that's about it for right now, until we get the water to room temperature. Okay, another cool thing to do with dry ice, if you have like a metal object like we have here, a screwdriver, it does this. That annoying sound which hurts my ears.
I'm not sure if it's even fun.
Do it again. Do it again.
It's not fun, but it's cool.
So it does. Dry ice does scream when it touches metal.
It's like a chemical reaction between.
Dude, it's like I'm like fake screaming.
Solid.
It's like I'm fake screaming. It's like, and then someone's like.
Okay, this is the first part of our experiment. We have boiling water, and so us kids over here, RJ's dad, who's videotaping this for us, is putting it in here so none of us get hurt right now. And we have 3 lines which are 4 each for our graph, and we're doing this first, the boiling water section. So, RJ, get one.
Get the timer.
All right. So
Start it whenever you drop it.
Just grab it. 3, 2, 1, go.
here we go.
We'll get that out of the way. We can actually see.
We're testing to see how long the dry ice will last.
Last inside this boiling water. And later on, we're going to test the amount of smoke that you see right now at the very end. Maybe. I don't know.
It's gone.
No, it's not.
It
It's
took
still
like-
right here.
Still,
It's still floating.
It's taking
A couple minutes. Like at least a minute.
a second.
that is much faster than I expected.
Actually, I got it.
So cool.
Now it's avoiding the sides. It's making a triangle.
Did you see that?
It's avoiding the sides.
Yeah,
It's gonna take a minute. I think.
It's right at a minute right now.
1 minute. Still.
Now about our reactions to this the dry ice, not showing in the cup, or it's still right here. My reaction was like, I was actually assuming for this time, because this is boiling water. Dry ice is cold, but boiling water will make it stop, stop,
1 minute.
stop,
1 minute and 20
like get away.
It boils away a lot
Oh,
faster.
boils away a lot faster. RJ's reaction was.
I think it was. I thought it would boil, evaporate fast,
Longer.
a lot longer, even though it's dry ice. Thing is, my reaction is, like, I'm just mind blown by how fast that melted, even though.
Want to do another one?
Yeah, we're gonna.
To do the how many? Like a minute and 23 seconds for that first one.
So it's about a minute 23 seconds
I'm gonna
for
put
this
all
one.
this. So.
Okay, boiling.
I'll put
First.
the numbers up here.
Hopefully that's still hot.
Touch it like, inside.
Still pretty hot. Still boiling.
Alright.
Yeah, it's probably gonna lose a little bit, but it's probably gonna be still the same amount.
going to test the cold water. Alright,
And
let's get the timer ready.
Mark, if my brother gave you something, are you gonna give me something?
reset it. Stop, reset. Starts now.
I bet this will take a long while.
Yeah, but it's cold water mixed with cold.
Makes it more cold and freezing.
And you can see that the
Are you gonna give my brother something?
It's right at the bottom instead of staying at the top.
What if it's a sinking?
is that the steam. I guess technically it is steam.
Yeah, that's all.
The steam is not coming out as fast as it is when it was in hot water.
I will take these blow worms off.
Okay.
It's about 4 minutes.
And
And it's not even gone yet. It's almost.
It's
but
there.
We had to stop it because
It's
just say 4 minutes and 5 seconds.
yeah, write that down.
It's about 4 minutes and
Wait,
5
you just said
seconds.
asleep.
So.
Mark.
Yeah, 4 minutes. 5 seconds.
Okay.
The key for the room temperature, which is our key. The average was 3 minutes and 28 seconds. For the boiling water, it was 1 minute and 29 seconds. For the cold water, it was 4 minutes and 9 seconds. To make sure when you do dry ice experiments, make sure you have safety. Wear gloves so you don't get hurt. And dry ice is like really cold. It's heavy duty gloves, yes. They're really cold, so if you touch them with your bare hands, you'll burn yourself. So be careful. Thanks to my friend here, I forgot his name, I'm so sorry. Rainier. He helped us with the dry ice parts. Thank you, Rainier, and goodbye.
Also,
And also, in conclusion,
In conclusion,
as the temperature goes up, the faster it boils.
Yeah.
yeah.
Okay, yeah.
Okay?